All right, this quick concept review for our kinematics is going to focus on speed and velocity. So we've been doing a little bit of these quick reviews for your kind of MCAT review in physics, and I want to encourage you that there is a much longer and more detailed mini lecture on the concepts of speed and velocity. So if this is a little bit too fast, make sure to go check out those longer descriptions in the kinematics and 1 and 2 dimensional motion and describing motion playlists on the channel, because they'll go into a lot more detail with a few more examples. But to just cover our quick review, we've been describing motion, so this discussion of kinematics, and we previously talked about describing how far something went, and speed and velocity answer the question how fast an object is moving when we want to describe that object's motion. So let's contrast and compare speed and velocity. So speed. Speed is our scalar quantity. It is related to an object's distance, so how far an object has traveled in terms of its distance, its total length, in the amount of time that that object travels. So distance per time. Our distance unit is in meters, and our time base unit is in seconds. So speed is going to have the unit of meters per second. So if we go to that example we used when we introduced the idea of distance and time, we had that farmer moving around her rectangular field, and we're going to say that she goes in a circle around her field, and one length of the field is 1 kilometer, and the short length of that rectangular field is 1/2 kilometer. So if she were to do this whole trip in 600 seconds, so 10 minutes, she takes that wander around her field. All right, how do we calculate the speed? So the total length of her travels is the distance. The total time of her travel, of course, is that time. So the distance would be 1 kilometer plus 1/2 kilometer plus 1 kilometer plus 1/2 kilometer. So our distance is 3 kilometers. Our time is 600 seconds. We want that in meters per second. So 3 kilometers is 3,000 meters in 600 seconds. So, whoops, I forgot that S there. So we have her rate of travel at 5 meters per second. So just over kind of normal walking pace, which is about 3 meters per second. All right, so that's her speed. Looks at the total lengths and the total time it takes her to cover that distance. The other way we describe how fast is the velocity. Velocity is our displacement per time. And displacement, remember, had to do with the relative ending position to the beginning position. So where the object ended up relative to where they started. And so our displacement, that change in object's position per time, also is going to have the units of meters per second. Displacement is going to have meters, time is going to have seconds, or velocity is going to have the units of meters per second. And because displacement is a vector quantity, velocity is a vector quantity. So it too will have direction. And we will have to pay attention to that direction as we consider the object's motion. So first we're going to talk about sort of the average speed, the average velocity. So if we use our same example up here, the average velocity, how far did this farmer walk in that 600 seconds in terms of its velocity? Well, if velocity is our change in that position, our change in where the object is located, our displacement per time. Well, she started at the house, she ended at the house. She had an average velocity of 0. She started and ended at the same location. So we can see that the average speed in this case was 5 meters per second, The average velocity in this case was 0. She started and ended at the same location. All right, so slightly different conversations about speed and velocity. I also want to talk a little bit about, this was our average velocity, about instantaneous velocity. So I'm just going to erase this part of the board and give a brief overview of that. Again, there's more detailed discussions of that in a longer lecture, but just to review this idea of instantaneous velocity. And the reason that's going to be important as we continue to examine motion and kinematics is because our instantaneous velocity is what we are interested in using often in our description of motion. How fast is the object going at a very specific point in time to understand how fast it'll go later, or where it might end up, or how its velocity might change. So we need to understand this idea of instantaneous velocity. The instantaneous velocity looks at this displacement per time as the time gets smaller and smaller and smaller and smaller and smaller. So our instantaneous velocity is the limit as time goes to 0 for my change in position over my change in time. So as that change in time gets smaller and smaller and smaller, I'm looking at that change in position at an instant, that instantaneous velocity. This actually leads into the, this leads into the derivative of the position is a representation of that change, that instantaneous velocity. So what is the velocity at a very specific point in time? And one way to think of this kind of in our own general sense is that if I am traveling between two cities in my car, I'm driving my car between two cities, on average, let's say that city is an hour away, on average, I might be going 60 miles an hour. So it's 60 miles away, takes me about an hour. On average, I'm going 60 miles an hour. That's my average velocity. Turns out that's probably my average speed too. If it's a straight shot to that location. But what about my instantaneous velocity? Let's say at some time during that trip, I got behind a tractor. And I lived in Wisconsin, so I got behind a tractor and I had to slow way down. I look at my speedometer and I'm going 45 miles an hour. I guess that's a fast-moving tractor. I'm going 45 miles an hour. Later, I want to make up that time. I only want to take me an hour, and I need to get in front of that tractor, so I pull out to pass him, and I have to speed up well past 60 miles an hour to get in front of that tractor. Because there's cars coming. I have to go super fast. So at any one instant, I'm not going 60 miles an hour. But if I look at that very split second point in time, look down at my speedometer, that's my instantaneous velocity, as opposed to that average velocity across the whole trip, across that whole motion. So we're going to actually use both of those in our descriptions in our problem solving when we look at kinematics and describing an object's motion. So I want you to get a sense of the difference between those two. All right, so kinematics concept number 2, how fast an object is moving is one of our concepts. Great job.